Okay, so this is the expression we derived. At 0 Kelvin, Fermi level lies exactly halfway between EC and donor level ED. This is what I just explained. As temperature increases, more and more electrons from your donor atoms are going to go into the conduction band. So Nd by Nc is going to be negative. So your Fermi level will fall. Why is this happening? Because Nd is going to decrease. Nd is the number of donor atoms you have which have not yet lost that extra electron. So as I give more and more heat energy or optical energy or electrical energy, more and more donor atoms are going to lose that fifth electron. So the number of atoms which have not yet lost that fifth electron is going to decrease. So when this term decreases, this ln Nd by Nc is going to decrease. It will become less than 1. So the ln Nd by Nc term becomes negative. So EF will actually start decreasing. So initially it was halfway between EC and ED. It was this red line in the diagram you see. As your temperature rises, it starts falling like this violet line, and when all the donor atoms have been ionized, that is when Nd becomes 0, your EF comes to your original level, that is EC plus EV by 2. When all your donor atoms have lost that fifth electron, like I said, it starts behaving again like an intrinsic semiconductor, as in the silicon atoms, they lose electron hole pairs are generated. So the normal intrinsic behavior is shown at that point. So the Fermi level comes to EC plus EV by 2. So yeah, it starts from EC plus ED by 2, and as you raise temperature, it comes to EC plus EV by 2. Also, when you're doping with higher concentration of impurities, the Fermi level drops more slowly. Meaning, when I am doping is adding impurities. So when I'm adding more phosphorus atoms, then it will drop at a slower rate. Why? Because if I have, let's say, 5 phosphorus atoms, let's say it takes 250 Kelvin of energy to bring the Fermi level from the initial position to the original position, that is to the intrinsic condition. Now if I have 10 phosphorus atoms, there are more electrons to be lost, right? So you will require more heat energy. So if it took 250 Kelvin in the first case, it will take 500 Kelvin now, or more energy. So that it will still drop in the same pattern, but the time taken will be more.